Hello, everyone, and thank you for joining us for today's session. My name is Askia. I'm the facilities coordinator for the Redmond Reactor Space. And before we start today's session, I've got a few things I'd like to go over, so please take a moment and read our code of conduct. We seek to provide a respectful environment for both our audience and presenters, and we encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will be shared throughout the chat. So keep an eye out for that. And this session will be recorded and it's going to be available on demand on the Microsoft YouTube channel within 24 to 48 hours. That brings us to today's session. It's going to run approximately 1 hour, and there will be time for questions throughout. So I will now turn it over to our speakers.
Hello, everyone. Welcome to our series on securing AI apps on Azure. This is actually our 5th stream in the series, and we only have one more after that. I'll introduce myself. I'm Pamela, and I'm a Python advocate, which means I help Python developers use Microsoft tools, especially Azure tools, VS Code, that sort of thing. And then I'm joined by Matt.
Hi, my name is Matt. I'm a program manager on AI Search.
All right. Thank you, Matt, for joining today. And if we could, there we go. So switching over to my screen here. So today we're talking about how we can add data access control for RAG applications that are on Azure. And we're going to be using specifically Azure AI Search for this. So first, let's talk about what is RAG. RAG stands for Retrieval Augmented Generation, and it is a way that we can get answers from LLMs that are grounded in some particular knowledge base. So for example, if we have a user ask a question and they want to know about the particular company, do my company perks cover underwater activities? So we get that question. And the first thing we do is actually use that question to search some knowledge base. And we get back results for matching documents or chunks of documents that we think might answer the question. And then we take those results, usually like 3 to 5 results, and we send both the original user question and the search results to a large language model like GPT-3.5 or GPT-4. And then we get back an answer with a citation. So that is the RAG flow. And we have a fully featured RAG solution that you can get started with that implements both simple RAG and advanced RAG. So I'll start off by showing the simple RAG. Right, so here's the question I had from the slide. Do perks cover underwater activities? Okay, so it says underwater activities such as scuba diving are covered under the Perks Plus program. And you notice these citations here. So when you see citations, that is a good sign that you are looking at a RAG application because it's showing that it is grounding an answer in those citations. And then we can look at this thought process we have here and see the flow, right? So we get that user question. We use that to search an AI search index, and we get back these search results. And these are chunks like, paragraphs from these HR documents for this, for this particular company. It's a made-up company. And within them contains the answer. So what we do is we send that original question and the sources to the LLM. And so these are, the system message that says, hey, LLM, you better answer based off the sources. Don't go off script, right? And then we send in the user and the sources questions here. And then we get back the response that's grounded. So this is what we call a basic RAG flow or simple RAG flow. Now, what we normally actually use is a more advanced RAG flow. So let's go over here and ask the same questions. So do my perks cover underwater activities? I think that's what I asked. We'll see. So I'll go ahead and submit that question. And in this time, I actually got a slightly different answer. So I might have asked something slightly different. And what we'll see also is that the thought process is different. So I'm going to go ahead and click on the thought process here. And this one starts off with what we call a query rewriting step. So that's where we take the user's query and then we turn it into a better query. And we actually use an LLM to do that. We say, hey, LLM, here's the user's question. Can you turn it into something that would be a good query for Azure AI Search? And this can be really helpful because it can, fix spelling mistakes. It can, word something better. And it's really, really helpful when we have multi-turn conversations, when we have follow-ups, right? If we said something like, what other activities are covered, the user is assuming that the LLM, knows what it saw before. But it doesn't really necessarily see that. So we can take a question like that and flesh it out and add more context as to what the previous questions were. So this query rewriting stage is really, really helpful. And it's a relatively quick call to an LLM. It's a part of most RAG applications. So we get that generated query. So this, you can see the generated query is perks underwater activities coverage. So that's a pretty good query. So we use that to search the index and we get back what looks like pretty much the same results. And then we send that to the LLM. So the only difference here is the addition of that query rewriting step, but it is a really important one. So I always like to show it. So that's the demo. And this, this solution, this RAG solution, if you want to get started with it today, you can deploy it. Just go to aka.ms/ragchat and follow the steps. And you can have this deployed and you can try it out with your own data to see how it works for your data. And it is the solution we're going to be showing throughout this whole demo. So for example, I have a version of it that's on my personal blog. So I ingested all my blog posts so that I can ask questions about myself because, I've lived a long life and sometimes I forget, right? Especially good sleep strategies. Like last night, actually, I was using a bunch of these because I'm really bad at sleeping, which is why I have so many blog posts about it, because eventually one day I'll learn. Yeah, I did that. Darn it, I didn't do that. So you can make a RAG on so many different data sources, right? You can make it on different kinds of documents, whether it's PDFs or Excel or PowerPoint. You can make it on web pages like I did here. So it's really, really cool what you can do with building a RAG application. And the solution that we're showing here today, this is the general architecture, right? We get this question that comes in. We use it to search Azure AI Search. And that is an index that has all of our data sources ingested. And then we send that to Azure OpenAI. Now, a really important part is the data ingestion. So, we were saying that we can make a RAG based off PDFs. We can make a RAG based on my blog. How do we turn these different data sources into documents that can be searched? So we have this data ingestion process, which we can do in a local script or we can do online. But the general flow is that, we get the document. First, we upload it to blob storage so that we have a way to show a citation. Let's see if my citations will load here. Yeah, so here you can see this is my blog post, but stored in blob storage. So we upload it to blob storage so that we have a way to show the citation. Then we need to extract all the text from it. So we use Azure Document Intelligence to extract everything that we can from it. And it'll even do OCR on images. It's really, really cool. And it can work on a huge number of file types, including PowerPoint and Excel and all that. Then we split the documents, all that text that we extracted, we split it into chunks. And this is a really important step that we need to do because we can't send massive documents to LLMs. Depending on the context window, each LLM has a different context window, right? Some of them allow 8,000 tokens. Some of them allow 32,000 tokens. I guess some now allow like 128K tokens. But even if they allow that many tokens, it doesn't mean you should send that much data to an LLM. Because generally, if you send a lot of information to an LLM, it gets kind of lost and it may not pay attention to the salient points. So we want to chunk things up into good sized chunks. We usually do about 500 tokens. So we split the data into chunks. Then we vectorize the chunks. So it means we compute a vector embedding for each of the chunks so that we can later do a vector search and a hybrid search on it. And then finally, we store it in Azure AI Search. We store all of the chunks from the documents that we ingested. So that is our general workflow for ingestion. And that means that we can work with all sorts of different documents. And here is just simplified Python code to show you what the code looks like for a RAG solution. We're going to be building on this, throughout this. So this is just to give you an idea in Python what it looks like to build RAG. So here I'm doing the query rewriting stage. So I tell, I do a chat completion and I say, okay, this is the query I want you. This is the query I want you to rewrite. Then I use the suggested query in order to search Azure AI Search. And I do a hybrid search with semantic ranker. And this is how you're going to get the best results from Azure AI Search. It means you're doing a full text search, you're doing a vector search, you're merging those results, and you're doing a semantic re-ranker on top, which is going to sort things better according to what matches the query the best. And that's where you get the absolute best results. And that's the best practice there. And now that we have those results, we can send the question and the sources to the LLM to get the final answer. So that's a really simplified code flow there. You can see the full code in our repo. So that was RAG. And now we're going to go over to Matt to see how Matt added data access control to this RAG solution.
Thanks so much, Pamela. So yeah, let's talk a little bit about how we have this RAG application and let's chat with our data. In the case of blog posts, they're on the internet, everyone can see them. We don't worry too much about who's reading them. A lot of times though, like let's say you're working for a business, there are many documents which should not be publicly shared. You can't even necessarily share these documents inside your business to everybody that works there. Maybe there's some sensitive sales information or company plans you don't want everyone in the company to know about. So let's show a little bit about what that same demo that Pamela showed would look like if we had this login button. So you're going to see that I now have a user identity here, and I can click the developer settings tab, and I can actually see, we're going to cover a bit more about what these extra options mean later in the session, but we're going to see that I have this concept of this thing called an ID token. So there's an identity I have. So when I ask it questions, and I'm using a different data set than Pamela's blog. I'm just using the standard Contoso fake company insurance that comes with the demo. So it's actually going to deny the fact that, hey, I want to know my health plan. I don't know anything about the health plan. So we can go to that same thought process tab, and we've changed the query slightly. We've added something called a filter. But essentially what's going on here is even though there are documents that talk about this in the data set, they're not coming back into search results. And if we think about that diagram that Pamela showed earlier, if the model doesn't know about your data, it can't answer any questions about your data. So that's really the crux of how we're going to implement access control. We're going to deny the model access to search results that it could use to answer the question based on the user's identity. So the actual architecture of this looks very, very similar to the original architecture. All we're really doing is we're adding this little tiny filter in the middle. I could even kind of show you some simple code where basically it's literally just saying like, hey, if we're using this OID object ID is basically who you are. It's a unique identifier in any security groups you're a part of. Just add those to the search query. That's really all this is. So it's not super complex to actually implement the filtering itself. But we need to learn a little bit about how authentication works in Microsoft in order to actually set it up properly. So we're adding a couple of extra components in play. The main new thing that comes in here is called Microsoft Entra. Microsoft Entra is how we do authentication and authorization of users in the Microsoft ecosystem. We have multiple parts to this demo. The two main parts of this demo are a single page application. This is what we're going to interact with and see here. This is actually a single page. I'm running it on my laptop, so that's why it says localhost here. But what's happening now is we've got this server running. So I'm going to pull over my command line running. So there's this server that I'm just running locally, and this is some logs coming out of it. So these two applications are going to interact. First, when I open my demo, I've pre-logged in to show you that, but I can log out. So I'm going to pop a window. I'm going to redirect. So this is the same, by the way, if you ever logged in using a Microsoft account, this is the same exact experience. You can add this very easily to any application you create using a SDK called Microsoft Authentication Library. So when I click login, you can even customize this landing page. I'm using the default where it says Contoso demo, but you can all this is customizable, like the look and the feel of this page. So I'm going to sign in using my Microsoft account. I am going to get an authenticator pop-up. So there are things called access policies you can define on Entra tenants. So you can enforce secure practices like, hey, you need a second factor to log in, a password's not enough. So that whole login experience that you just saw, that's all mediated by Microsoft Entra. You essentially just write the client like, hey, initiate that login code. It is effectively just saying like, hey, I want to acquire a token. That's pretty much the level of complexity you have to deal with in your code, which is really nice because creating these dialogues for anybody that's ever done that you can know that it can be very challenging. So once you've completed that authentication code, we get this token back. So that's where this code, we kind of get this access token coming back. So what is this access token? If I go into developer settings, this is actually what's called an ID token, which is slightly different, but it's a very similar concept where it's packed full of these things called claims. Claims are just, think of it as a JSON object. You got key and value pairs. And the really special thing about this JSON object compared to other ones is that every single element in this JSON object has been cryptographically signed by Microsoft Entra, which means that you can verify that nobody forged tokens. You might be aware of security news, you might see a lot of companies get hacked. A very common way web apps like this get hacked, they don't get hacked. Nobody hacks the mainframe. What they really do is they just forge these tokens and they rely on the fact that these are not verified. So a really key part of accepting these tokens is verifying that it's actually from Entra. So when we send this token to the API server, we actually include some code in the sample that it basically teaches you how to validate the access token that actually comes from Microsoft Entra. And it's not just something the customer made up. So once we've authenticated to the API server, we need to actually take that token. We validate it from Entra. We then exchange it for a token because there's actually two Microsoft Entra app registrations going in here. To see that login dialog that we saw in the single page application, that requires a single Entra registration. If this was a traditional web app where the API server was generating all the content and serving it, only the API server would need an Entra app. But because we're using a fancy JavaScript single page application, we're going to need a registration per every one of these. So once we've got the token from the single page application, the API server is going to take that token. And if I scroll up here, it's going to turn around and it's going to actually use this handy dandy Microsoft Authentication Library method called acquire token on behalf of. And essentially what that does is it says, hey, I've got a single page application. It gave me a token. I have my own application. I need to take that token and exchange it for one I can now use to call a Graph API. What are we going to do with that Graph API? Well, that's a great question. So I talked a little bit about token claims already, so I'm going to skip this slide. And I'm going to jump right back into how are we actually going to represent access control. So we saw in the demo, we're using my identity to filter documents, right? And I already mentioned, hey, I can filter documents based on what is my user ID, which is just think of it as a GUID, globally unique identifier that identifies me in a single Entra tenant. So if I go to my token claims and I see this little claim called OID, this GUID, I see 684, whatever, that's Matt's identity effectively. But, if you just filter based on user identity, you have now another problem of, well, if I've got thousands of PDFs and a user is supposed to access 5,000 of them, and I've got 20 users, that's a lot of manual updating you have to do. You have to kind of keep track of the user's identity. So another strategy that's very common is to use this thing called groups, which groups are also GUIDs. It's just an array of GUIDs that basically says, hey, I'm part of let's say Python users. That could be a group. There's a GUID associated with that. There could be Java users. That's another group. However, you could have so many groups, and I can tell you at Microsoft, we have so many groups that transferring them back inside the token claims, it doesn't really make much sense. The problem is that these tokens have a limited size. They need to be efficient. You're sending them on every request to authorize them. So instead of sending those claims on that token, because that's the cryptographically verified thing, you can't fake group membership. We're going to use what's called the Microsoft Graph API to query information about the user and ask, hey, what groups are they a part of? So then finally, we can go and actually either store these in the index or use it for the filter. So actually adding this capability to the index is super simple. There's a special attribute in AI search called filterable. And this attribute is different because we were talking about RAG before. We're talking about, hey, I can do full text search. I can do vector search. Filters are these really precise way to slice your search results even further, where it's great that you do a full text match and match over tens of thousands of PDFs. But if you want to look at that subset of PDFs I can access, that's where kind of adding a custom metadata filter is going to be really important. And you just have to remember that you need to mark fields you want to add metadata filters to with this filterable attribute. In our search code, what you're going to see is it's a very simple code. There's literally this special type called simple field, which helps you implement it. And you just set filterable with a true. There's not much to this. Now we get into the actual construction of the filters. So you might think it's well, hang on a second. I've got tens of thousands of PDFs. I have to check each one, right? I have to do a full table scan or something. Well, actually, we have a really efficient index for filtering. And the syntax looks a little funky. It uses a terminology from the standard called OData. But basically, if you use this syntax, you can use this special OData function called search.in that we've defined. It's only part of AI search. You won't find it anywhere else. But effectively, it takes a bunch of parameters. It takes a single field name. So in this case, I'm going to actually apply it using a lambda syntax saying hey, I've got my object identifier field. If any of them are actually in this giant list of GUIDs, it's okay to include in the search results. And this is very efficient for AI search to evaluate on filterable fields. So you won't pay any performance penalty when you're querying using access control. Again, if you're interested in the kind of how do I actually implement building this filter, we have a method here that actually does it for you. So you can just kind of copy paste this and either use our sample or lift it directly into your code. So we understand how to build the index. We understand how to actually filter. How are we going to get this access control information into my index? Prep docs that we just showed does the local thing. It has some extension for adding authentication information into the index. We're working on improving this actively. But basically, the way you do it is you use the same API that AI search uses to update documents. It supports adding arrays. It supports adding basically any field we support, you can update. So what we do is we have different types of search actions when we're updating documents. We can either just plain add them. And if we're just adding them, we have to specify every single field in the document again. Think of it as an overwrite. There's another action called merge, which basically says, hey, the document needs to exist. And if it exists, only update specific fields on that document. The one thing you have to keep in mind when we're using the merge action is it doesn't merge arrays. So unfortunately, you're going to have to specify every single permission every time you update the groups or the object identifier fields. But you don't need to update every single field. So let's say you've chunked and embedded your documents. That took a lot of time. Maybe there was some costs associated with it. We're using Azure OpenAI embeddings. We don't need to recompute embeddings or rechunk to update access control. We just need to know the unique identifier of the document, and then we can go and we can actually update it. So this is all great. We know how to update access control. We know how to filter. We know how to define it. How are we actually going to link our data? It's a very common pattern, like what Pamela did. It's hey, I downloaded all my blog posts. I put them in Azure Blob Storage. There's a certain type of blob storage called Data Lake Gen 2. And it adds a bunch of useful features to blob storage. Namely, the feature we're really interested in is it actually adds the ability to specify access control metadata on files and folders. This special syntax you're seeing here, if you've ever used Linux before, this is the same syntax Linux uses. I believe it's called POSIX access control lists. So there's going to see this RWX. It stands for read, write, and execute. These are really specific meanings in data lake storage Gen 2. You're not actually executing any code or files. These basically, think of these permissions as we're conforming to the POSIX standard, but we've kind of mapped the meaning of them to make sense in data lake Gen 2. So when I see this X, it does not actually mean execute. It actually means directory traversal. This user's GUID, they would be allowed to list all the contents of the directory. So just like AI Search has a Python SDK, Data Lake Gen 2 also has a Python SDK. This is also simplified code, but there's this really simple method called get access control. It has this really fancy parameter called user principal name. And by default, it does a really fancy thing. It will like return the nice username. Like it will return my full, like, oh, I'm Matt, I own this file. For our purposes, we don't actually want that. We want the GUIDs because we're going to use GUIDs for filtering. So we actually have to turn that off. It's on by default. But once we turn that off, it's just a matter of saying, hey, there's an access control key in the dictionary, and then just split it on the comma. And then there's some more parsing code included in the prep doc solution, but you'll be able to use that if you choose to use Data Lake Gen 2, if you're following this blob storage pattern. So at a high level, access control on your data, how do you manage it? There's not a right answer, but there's two general patterns that emerge. You could just say, hey, I want to store all my documents in a data store with access control. If you can set up your data such that you can do that, that's great, because your data is co-located with your access control. You can make sure you don't lose any information. Sometimes that's not possible. Maybe you have a really legacy data store. Maybe you just have loose files on a hard drive you found and you now want to enhance it with access control. You'll have to perform some kind of join later on. And that's where that merge action I showed can be really helpful, because you want to get all your data and you want to test that your RAG works. Then you worry about enabling access control. I don't think there's a right answer. It really depends on your scenario and where your data is stored, and if it's even possible to store it with access control information. Of course, this is all fine and great. There's another option, right? If I have 10 users, they can each have their own index in AI Search. AI Search services support multiple indexes per service. So why, if I have 10,000 people working at the company, why don't they each have their own private index? Unfortunately, this kind of breaks down when you realize that we can't support 10,000 indexes per service. The most indexes we can support per service is on this particular configuration called standard 3 high density. It has a big limitation though. Each of those indexes can only be 100 gigabytes, which can be pretty small, especially if we're talking about doing RAG over like large corpuses of documents. So this is a valid approach if you have either few enough users or your use case is really targeted. The filtering use case, the big advantage you have there is even if you have fewer users, you don't need to maintain multiple copies of data across multiple indexes. So that about covers it for access control. I wanted to hand it back to Pamela to talk about user uploaded documents.
All right, we do actually have a couple good questions that we might want to cover now.
Let's cover the questions.
As a first question, is Azure AI Search based on Solr or Elasticsearch?
We support the Lucene syntax, which looks a lot like Elastic.
Okay, I thought it was something like that. And then we have various folks like excited about this and figuring out how they could use it for their RAG. So one question is, if the data is in SharePoint, how could we implement access control in our RAG app?
That's a great question. You can actually do RAG using the Microsoft Graph API directly. It supports a search option. If you do want to get it into AI Search, we do have we call it indexers, which is kind of like AI Search Managed Ingestion. There are also multiple solutions, open source solutions that kind of show you how to copy SharePoint data out into blob storage. But I think the biggest problem with doing RAG over SharePoint is maintaining access control. SharePoint access control is very complex. You have to take into account things like classification labels on your data. you might also want to try Copilot Studio. Copilot Studio will handle all this access control for you. The only drawback is you won't be able to kind of like build it in your solution in code. You'll have to use the Copilot Studio editor.
Okay, yeah, that makes sense. And then a kind of similar question from Raganesh is that they're developing a Teams Copilot, and and they're obviously using Entra ID and groups and want to implement data access control, and they have their data is either coming in from M365 using a custom graph connector, or it's also in data lake. So how could they implement it? I think they're not using AI search, right? So a question, if you're not using AI search, how would you use this?
So one thought is you can keep your SharePoint data in SharePoint and use the Copilot to search that. You can keep your data lake data, make it searchable using AI search, and you can actually federate those searches in your app. So you don't necessarily have to do 100% of this in AI search, because AI search is a really good fit for data lake data, but due to the complexities of access control in SharePoint, it's not always a great fit. So federating these two together in your application might be an approach you want to consider for the complex scenario like that.
Yeah, I think in that case, it's actually the same data in both places, maybe. But yeah, this is a good point that generally, if you have multiple data sources, you can run searches even concurrently, and then send both those results to the LLM. And I think generally, like if you're not using Azure AI Search, these same principles hold, where you can just make sure that you are storing ACLs on the documents and just honoring those at every point in the process. Cool. All right. Those are our questions for now. So I am going to talk about how to, now that we have this data access control just generally for all the documents, how can we let users upload documents? So this is actually a feature that I added after Matt added access control, because I'm like, well, I think you made it easy for me to implement this feature that everybody wants, right? So let's do the demo first, so we can see what it looks like. So here I am logged in, and this is logged in the same way that Matt showed. And now I've got the user upload feature enabled, which gives me this button up here for manage file uploads. And so I can click on this, and it's going to load in and figure out what files I've already loaded. So these are all ones that I've uploaded for myself. You can see it's a mix of HTML, Markdown, PowerPoint, PDF, etc. And if I wanted to, I could, go ahead and upload a new random documents, just whatever is in my downloads. This is the most diverse rag you've ever seen. Oh, and I got an error on that one. Funky. All right, I'll have to look into that error later. But that's okay. Let's ask a question about something that's here. So I actually uploaded the slides for today's session so that I could ask about data access control. So I'll just ask this, fairly generic question, like how to set up data access control. Oh, I wonder if my token. Oh, interesting. That was a 500. Okay, I'll check that out. All right. Okay. So good. It was able to answer. So it's interesting. Actually, it's grabbing things from multiple things that I've uploaded. So it's, we've got here about ADLS. Oh, look, it's got the ACA that we just shared. That's great. It's so meta. So I wonder what it's going to look like in the citation here. So here I asked a question and I got an answer, and only I would have gotten that answer because this was a doc that I uploaded for myself. So I basically built on top of, the ACL stuff that we already had. So what you can see is that when we do the filter, we have that, we have the filter that Matt showed. So I've got my OID here and my groups. If I look at, the developer settings, I can see my OID is there's so many things here. It's hard to, object identifier here. It's object identifier. Yeah. So I pass that in and I get the results, and you can see these results. And in these results, you can see that, like this one, the OIDs is only, only one person has permissions for this document, and it's me, right? And then with this one, it's only one person and it's me. And this one, it's only one person and it's me. so, so the search is working really similar. Doing the upload was, something I had to add, and so I made some design decisions there. So when I get the new document, the first thing I do is I upload it into an ADLS2 account. So, Matt was talking about ADLS2 or Data Lake Gen 2. It is basically blob storage, but with ACLs and, hierarchy in it. So what I do is that for every user, I create a directory for them, like a folder, and I name it based off their OID, and then I store all their documents in that directory, and I can even give them permissions to that directory. So I thought this was a really nice fit for user uploaded files, because we can say like, well, we know these files were from the user. Let's go ahead and store it in such a way that reflects the fact that they all came from the users. So I add a new file, I create the directory if I need to, or I reuse an existing directory for the user if it's already been made. I set the access controls on that directory to both give, the app permission and the user permission. So if they needed to delete their files at some point, they could even do that programmatically. Then we do the usual data ingestion process, right? We extract using Azure Document Intelligence. We split it into chunks. We vectorize the chunks with embedding models, and we add it to the index. Now, when we add it to the index, we set the OID, and it's going to be an array with a single value. And we set the other things, and we also set the storage URL so that we know exactly which file this chunk came from, right? Because this URL here is unique to this user, this document, because you can see this is my ADOS2 account, and then this is the user content folder, and it has this directory, which is my OID, and then this file. So we can tell that this is unique to this user. And the code, the simplified code looks something like this, right? When we get back a request from the user to upload, we get their OID from the auth claims that are in the token. We get the file that was uploaded. We either get the folder for that user, or we create the folder if it doesn't exist. We set access controls on it, and upload the data to it, and then ingest the file. So we can even actually go to the portal and just check out to see what that looks like. So let's find my, here we go, auto authy. Okay, all right, so here I'm looking for my user storage account. So here I've actually got a separate storage account for user uploaded ones than the globally uploaded ones. I thought that made things a little cleaner, but if you're using ALDOS2 for everything, you could just use the same storage account. Here is the user content directory, and then if I look under here, we can see two directories. Matt, is this your OID? Have you memorized your OID?
I don't know. Maybe it's me.
Maybe. Not very exciting things to upload. You should upload more exciting things. And here we go. Here's everything I have uploaded here. And yeah, so you can see that corresponds to what I've got here. And that's actually also I think that's how I implemented the list. That's a good question. How did I implement? So we have the ability to delete. So that deletes. And remember, when you delete, you have to delete everywhere, right? You have to delete from the Data Lake Gen 2. You have to delete from the index, right? You need to delete in both places. And yeah, when we list, I just look at the directory and see everything that's in the directory. So you do need to keep things in sync, and be careful to keep things in sync. But it can work really well for being able to do user uploaded files. Oh, I also wanted to show the citation, right? So when we click on a citation like this, and we see it load. Now, sometimes people think that we're using blob stored URLs with, keys in the URL, but we don't do that because that's not very secure. So what we do instead is that we are we're using so we don't actually allow keys on our blob storage, right? That's as a best practice. We don't allow you don't even allow you to use keys with it. So what we do instead is that we have a citation path. Let me find it in here. It's like content. Oh, we have a lot of content. Here we go. Okay. So this is our path that renders a particular file name. So it will be, we have a decorator here that checks to make sure you are authenticated if you should be authenticated, and to see whether you can, whether you can view it. And then we actually do a few things. We check both our original storage account and we check data lake to see where it is, to see whether, it's in either of those. And we're, doing all this authentication on our back end. So this is, going to be really secure. And then we actually pass down a blob. So we pass down a blob to the front end, and the front end renders that blob. And the blob looks great. So we do also have secure citations as well. Now, this does mean that our citations are a little slow to load because we're doing these multiple checks. So we're going to maybe try and improve this code to be a little more streamlined, to make our citations a little quicker to load. But that's another thing to keep in mind from a security perspective, is that, it's the search index, but it's also the citation viewer, right? If you're going to have documents that are only viewable by some people, then you have to enforce that everywhere where those documents can be viewed, right? So that's the search process, but that's also the citation viewer. And so that's something that we have to make sure that we're honoring the ACLs everywhere. All right. So that was user uploads, and you can follow the ACA in order to deploy the solution with user uploads and with ACLs, and you can get it going in a couple hours and then add your own data. Let me see about questions here. So we have a question: is there a specific blog about how to implement access control through Copilot Studio? Have you seen one, Matt?
I think the thing about Copilot Studio is when you are logged into Copilot Studio, it automatically uses your identity. So I apologize, I'm not a Copilot Studio expert, but because you're in Office 365, you're logged into your account, it knows who you are. I don't think a lot of this extra stuff I think that's kind of the core difference between what we're talking about in Copilot Studio, right? Copilot Studio is more of a kind of pre-built type solution where you can customize it. This presentation is really focused on building a Copilot-like solution from scratch where you need to worry about all these things. I think that is a key difference we need to be aware of. But yeah, I mean, I think I'm not aware of any specific things in Copilot Studio that talk about access control explicitly.
Yeah, we do have a blog post that is about what we described here. And so I do recommend going through this blog post. It'll, be a lot of the stuff Matt talked about here, but it also breaks down, a lot of the Entra stuff. So, this will just give you a good idea about what you want to be looking for in any access control solution. But yeah, as Matt said, Copilot Studio, is a more of a lower code solution, I guess. To be honest, I also haven't played with it much. So I think there's probably less flexibility, but there also might be better access control built in. So that's just something we need to explore. And I'll chat with Copilot Studio folks afterwards to see if they have ideas. All right, we had a question from Ichigo. If the data collection is huge, do you have the option to shard the collection in the search engine? That's for Matt.
Yeah, that's a great question. So provided the data fits within the storage limit, you actually don't have to worry about any of this. I think the great thing about AI search is a lot of these problems you'd have in a database, like how do I shard, what's the strategy I use? AI search handles a lot of that for you. We do have general performance tips on AI search in general, but they don't include sharding strategies because that's not something you control.
All right, and then we have a question about, is this applicable to data scientists and data engineers? That's a great question. So what we're showing here is a web application that's a full stack web application. It has a front end, it has a back end. And, so if you're going to be interacting with this, like it might be hard if your education is data science, if that's your training. However, lots of companies are going to be splitting up these sorts of tasks between the, who's doing the actual app development and then who's doing the prompt engineering and the RAG orchestration. So as a data scientist and a data analyst, I would recommend you to, open up some Jupyter notebooks and start just implementing RAG flows in a Jupyter notebook so that you can just see what that's like, try different prompts. I think, Matt, there's demos in isn't this the repo you have? Let me see. I'm looking for notebooks. This one. Does this have notebooks in it? Demo Python.
This is a cross-language repository, so we're looking at the Python one specifically. But basically, if you're ever curious, how do I do something specific in AI search? Actually, literally just updated this one before the presentation, so nice. I know what's going on here. So basically, anything you want to know about creating a search index, how do I do vector queries? We usually have a notebook for it, or we have the other languages have more limited samples. Python is the most extensive, but feel free to take a look at this, and we kind of cover a lot of very common patterns inside AI search.
Yeah, I'm just looking for a RAG demo. So somebody who wants to get started with RAG.
Oh, so if you go back to code,
mm-hmm.
So if you go to PhiChat.
PhiChat, nice.
Yeah, so this actually is an interesting one because it covers deploying Phi 3 and comparing it to GPT-4o. So not all of these have Bicep. Bicep is a template language for Azure where you can deploy things. This one happens to, but this essentially has, hey, how do I ground my conversation using Retrieval Augmented Generation using both Phi 3 or GPT-4o? And I think this was actually written slightly before GPT-4o came out and needs to be updated. But yeah, this is a great example of just RAG in a notebook.
Yeah, so that's what I'd recommend. If you're coming from the data background, get started with notebooks, and then, that's what you can bring to the table is understanding how to orchestrate flows. Everything we showed here was, with the OpenAI SDK and the Search SDK, but there's also many wrappers that are very popular, like wrapper packages, not like wrappers. So, you might be looking at LangChain. Like LangChain's the most popular one for Python. Llama Index is also particularly popular for for doing RAG stuff, and lots and lots of examples there. One that recently came out from Microsoft is, sorry, that was me filing an issue on it, but here we go, AutoGen. And this is a very agent-oriented framework, and they have so many notebooks, and there is actually one specifically on RAG. Yeah, this one. So you could try that one as well. So many of these packages provide all this documentation with lots and lots of Jupyter notebooks that you can get started with and start trying stuff out. Now, most of these require deploying stuff. If you want to get started without even deploying anything, have I got the notebook for you? So if we come over here, I have this Ollama Python playground. So Ollama is a way that you can run local language models. You can see I've got this little llama up in the corner here. That's my Ollama running on my machine. But we can also run it in GitHub code spaces in the cloud. So you can just go here and create a new code space, and you can start using Ollama from it. And that's all for free. These are all local models. They're not as powerful, but you can still experience the, what it's like to use an LM, right? So you do a little prompt engineering, get it to be Elmo or whatever you want to do. You do little free shot examples, and then my super basic RAG down here. But this is something that you can just run inside GitHub code space, and you don't have to deploy anything, or you can run it locally if you have a llama running locally. So I love that the small language models are making it more accessible for anyone to get started with this stuff. So there you go. Yeah, lots of options there. All right. I see another great question from Ichigo. In the hybrid search, do you do hybrid keyword search and vector search, and does it have LTR learning to rank? So yeah, Matt, I don't know if you want to take this. I'll show that we are doing both hybrid search, and we're doing vector search and text search, and we're using the semantic ranker. But you want to talk more about this?
Oh, just at a high level, yeah. So you can customize your searches using AI search. Basically, you can, if you actually go to the developer settings tab, you can actually choose which search method you want to use. So if you open that, you can actually see it's like, hey, I want to use vectors and text, or vectors or just text. You can actually do some comparison. You can check and uncheck semantic ranker. So if you want to see what the results look like with or without that. Regarding your question about learn to rank, we don't specifically support learn to rank. We don't have like a trainable model that like does ranking of search results. What we offer is semantic re-ranker out of the box, which is actually using the same technology that re-ranks Bing search results. But yeah, I think learn to rank is definitely interesting technology. But you can always take your search results, and if you have your own re-ranker, you can choose to use that instead of semantic re-ranker.
Yeah, and what you can see is that when I turned off in this one for turning off vector search and ranker, it actually couldn't answer the question. So you can definitely see differences when you change that. That's actually one of the biggest factors that I found for your RAG quality control. There's an amazing blog post. It's aka.ms/rag relevance. Let me share that so that we can get that in the chat. This was from the AI search team, where they did all these experiments with, with these different options, right? So hybrid, vector, keyword, hybrid plus semantic ranker. And they also figured out stuff like what's the optimal amount of tokens to have in your chunk. Where should you be breaking? Like, should you be breaking at sentence boundaries or token boundary, right? And I just really, really love this research. I've also run my own evaluation. So I have a blog post, vector search is not enough. Let me see. There we go. And you can see the evaluations that I've run on my, my blog RAG, and the results I got, they really echo what we see in that other post. But basically, vector only actually does very poorly, at least for my personal blog RAG. Text only does actually really well. So Azure AI Search is very, very good at text search. That's one of the takeaways from evaluations. Hybrid does better than vector on its own, but it's only hybrid with ranker where you get better than all of those, right? So, the big thing I recommend is, run experiments, run evaluations, right? Because this is all going to depend also on your particular domain, right? And kind of questions that you get in your RAG. But you should be trying to run evaluations with different settings to make sure that you're confident that you're using the setting that's, going to work really well for you. Do not use just vector search on its own. I think lots of people maybe are doing that now, and I just get worried about that because vector search on its own can be very noisy. And if you because here's the thing about vector search is that if you ask for what's the closest to a particular query, vector search will always get you a result because there's always something in the vector space that's closest, even if it's not really that close. So you end up getting a lot of noise in your search results. And if you send things to LLMs that aren't actually answers to the question, LLMs have a tendency to make stuff up, to be less grounded when you do that. So definitely do experiments, do evaluations. I've got a repo over here that's designed for evaluating the kind of app that we just showed. But you can also use it for evaluating other apps as well. And then you'll get back, you can see the kind of statistics that you get back and be confident with your decision. Okay, that was just spiel on relevance. Let's see, a follow-up from that is how to determine the chunk size properly for the vector so that the hybrid search is not going to be slow. So that's interesting wording. So I'm going to let you take that, Matt, because they're asking about performance of the hybrid search.
Yeah, so Pamela already talked about that blog post where we published a bunch of research we did on chunk size impact on vectors. So hybrid search performance is governed by a couple of factors. So when we talk about hybrid search, we're talking about the text search performance. I wouldn't say that like chunk size is going to have a material impact on the text search performance. Really, what affects text search performance is the complexity of the queries. I mentioned earlier that, hey, we support the Lucene query syntax. We support things like regular expressions. Those really slow down your searches. We don't recommend doing that. We recommend, if you're trying to do some really complex full text searches, to really investigate our analyzer functionality to kind of shape how the text index behaves. When it comes to vector indexes, we have two main types. We have what's called approximate. Approximate indexes are the default. We recommend them for most use cases. They use a technology called hierarchical navigable small worlds, or HNSW. You get essentially really fast vector search performance, even on massive amounts of vectors. The downside is that we have a separate quota for approximate indexes. That means that you have a certain amount of storage available to your search service. There is a separate vector quota that means you can't put more vectors into your approximate index that go beyond the quota. There's another type of index called exhaustive, which provides basically the true nearest neighbors. But in all of our evaluations, the true nearest neighbors are often very close to the approximate ones. So this is definitely, we talk about evaluating. We really encourage you to evaluate, do I really need to use exhaustive searches? And in fact, approximate indexes also allow you to perform exhaustive searches, so you can try it out before you actually go build an exhaustive index. Exhaustive indexes, unfortunately, they do slow down significantly as you add more vectors. So we always encourage you to start with approximate indexes, because that kind of gets you very good speed.
Yeah, and there's all the new things that the AI search team that y'all introduced at Build this year, like the idea of searching for like 50 vectors, and then you can just like narrow it down after that, right?
So we're adding a lot more knobs, a lot more options to customize your search. Whether or not you actually need that customization, it really depends on your scenario. I can tell you hey, pick the top act. So we have this parameter called K. Basically, when it comes to merging vector and text results, the number of vectors we actually use to compute the score before merging tends to matter a lot. We recommend a larger value like 50 is a good starting point. So we say K equals 50. There's a lot of parameters. Trying out all these parameters, it can be kind of overwhelming. So we recommend sticking with the defaults, and then you kind of explore those parameters if you find, hey, the results aren't quite what I want, or I'm having a specific problem. You can see we're looking at the tip to relevance tuning. So we have this K results issue. When you talk about, however, increasing the number of search results you put in your chat model, Pamela mentioned the context window. It's a trade-off between how much space do I have from the actual question my answer, or the search results taking up too much space. So these are all things that are scenario dependent, unfortunately. There are rules of thumb for like good starting point values, but it really depends on what you're trying to do.
Yeah, and what other setting that you can experiment is doing minimum search scores or minimum re-ranker score, especially with the re-ranker score. So re-ranker can vary between 0 to 4, and generally a score of 4 is really good, and like 3 is pretty good, and then like 0 to 1.5, 2, like not so good, right? So if you feel like you're often getting search results back that don't feel relevant enough, you could experiment with setting a minimum re-ranker score, and say like, oh, everything has to be at least 2.5, right? And you could try that. I actually did run an evaluation, I think, with 2.5, and for my use case, I didn't get better results across the board. But that's, once again, why it's important to run evaluations for your domain and run it on, a bunch of questions and answers to see on the whole how something helps or hurts your results. Okay, another question about Azure Search, just to follow that thread, is it possible to use the Azure Search Engine for multi-language purposes?
Absolutely. Both the full text and the vector side support multilingual search. For full text, we have language analyzers. It's just important to say, hey, I've got multilingual strings. Make sure you store them in a field that uses the correct language analyzer so you get the best results. When it comes to vectors, a lot of embedding models, including all the OpenAI ones these days, they're multilingual out of the box, which means that if you embed a like, hello, how are you in English, and you embed the same text in French, they're going to be really close matches. So this is really nice property of vector search that most of the embedding models that are really popular today are multilingual out of the box. So it's never been easier to have multilingual search.
And one final question was, is there a blog post that details strategies to add access control when we are changing our model and re-indexing or adding new groups to existing documents.
I think the blog post we have, it covers it in general, but not that specific scenario. But like, I think if you remember the slide I had about the 2 general strategies, it would fall under option 2, which is, hey, I've got data in the index and I'm changing it. So you can change the documents that are in the index to include the new groups. Definitely something is going to be dependent on how this information is specified, but that would be the general strategy I would take.
All right, so thank you everyone for all the great questions. And if you do try out our particular RAG solution and you run into any issues, please do file an issue in the issue tracker. You will see Matt or I respond to usually within a few days. And we love to get feedback, figure out what the big pain points are, figure out what are big things that people need next from a RAG solution, and to work with you all in order to improve it and make it easier for everybody to build RAG applications. So thank you everyone for joining. We have one more session in this series next week where we're going to take this RAG app and we're going to deploy it to a virtual network. So if you're interested in that, join us next week for that session. That's all we got. Thank you, everyone.
Thank you so much.
Thank you, everyone. If you have any, we'd love to hear your feedback. So please, if you have time, use the survey link that is on the screen and in the chat. The event code for today's session was 23025. Thanks, and we hope to see everyone next week.